now we are on problem 20. Two integers are inserted into the list 3, 3, 8, 11, 28 to double its range. The mode and median remain unchanged. What is the maximum possible sum of the two additional numbers that have been inserted? So let's understand this problem a little better. So our numbers are 3, 3, 8, 11 and 28, and let's also talk about the mode, median and range of this set of numbers. So the range is the difference between the largest and the smallest values, so that will be 28 minus 3 or 25. So the range of this set is 25. The median is the middle value, so the median in this case is 8, and the mode is the most frequent value, the one with the highest frequency, so the mode in this case is 3. Now what the problem is telling us is that two new integers are inserted into this data set so that the range gets doubled but the mode and median remain the same. And what is the maximum possible sum of the two additional numbers? So we have to preserve the median and the mode both. And what does it tell us? It tells us that the two numbers, one number should be to the left of 8 and one number should be to the right of 8, because we still want 8 to be the middle number. We can't insert 8 itself because then the mode will not remain unchanged because we will have two 8s. So first we conclude that we have to insert one element to the left of 8 and one element to the right of 8. And that will preserve the median and it will also preserve the mode. Now we need to double the range. So the new range should be 50, which means that the difference between the largest and the smallest values should be 50. So think about any two values, one to the left of 8 and one to the right of 8, whose difference is 50. So for example, if you take 1 and 51, so 1 is to the left of 8, 51 is to the right of 8, the difference is 50, and the sum of these two new inserted numbers is 52. But what we have to do is find that pair which gives us the maximum sum, and this is really the crux of the problem. So to maximize the sum, what we need to do is we need to find the maximum possible two numbers that still fit this constraint. So let's say the number to the left that we insert is x, the number to the right is y. So what we'll do is we'll try and make x as large as possible. So we can't make it 8, but we can make it 7. So imagine that we insert a 7 over here. And now what should this number to the right of 8 be? Remember, we need a range of 50. Now the smallest number in this set is still 3, which means that y cannot be anything other than anything higher than 53, because the difference between 3 and 53 is 50. So this means that if I insert 53 over here, my range becomes 50, which satisfies this constraint. Median stays the same and mode stays the same, 3, but this sum of 7 and 53, which is equal to 60, that is the maximum possible sum that is obtainable here. So the answer in this case is D, 60.